Hey VC students, welcome to another video of hok'stutoring. I hope you're having a great start to the year. Today we'll be going through a tutorial video answering question chapter 1C, question 25. So this is the last question of your subtopic on geometry using linear lines. And this is a highly requested question from my previous years of experience. So without further ado, let's get into the question. Let's have a read. Question 25. ABCD is a parallelogram with vertices labeled anticlockwise such that A and C are the points -1 and 5 and 5 to 1 respectively. So just before we even read any further, I want to make a disclaimer here. This graph over here in your textbook was actually, next to this question. But in fact, it's not the graph or the parallelogram that they're actually referring to in this question. Why? Because you can see that, point A has the coordinates -1, 5. Our point A over here clearly does not have the coordinates -1, 5. -1, your graph, your parallelogram should be on the left-hand side somewhere. So just be careful. This graph or this diagram over here belongs to the previous question. So question 24, that's where it belongs. Question 25, we're going to have to sketch our own diagram, okay? So we might as well get into that quickly. It's not too hard. Point A is -1, 5. So somewhere here, let's say this is -1. And then 5 is maybe somewhere up here. So let's say that is A. Gonna label that -1, 5. And then we have point C, which is 5, 1. So that's just the other side, a little bit over here. Point C, 5, 1. So we'll call that point C, 5 and 1. Right, so now we've got our 2 points. We just need to make a parallelogram. We'll do that. We'll complete the parallelogram as we go through the question. So, question A. Find the coordinates of the midpoint of AC. Well, this is very simple if you memorized or if you know your formulas. I'm going to answer the question down here. We will call, so let X, or you can put M, up to you, be the midpoint of AC. So how do you find that? Well, the formula is x1 plus x2 divided by 2. That's the midpoint for the x coordinate, and then the y coordinate is just y1 plus y2 divided by 2. And then all you need to do is plug in the numbers. We know that x1, x2 is -1 and 5, the x values. And then you divided by 2. And then y1, y2 is just 5 and 1. So 5 plus 1 divided by 2. So therefore, your x coordinates or your midpoint of AC is just, so -1 plus 5, that's 4 divided by 2 gives you 2. 5 plus 1 is 6 divided by 2 gives you 3. So there we go. That's the midpoint. Nice and simple. Let's move on to the next part. Given that BD is parallel to the line with equation y plus 5x equals 2, okay. Find the equation of BD. Right, so we know BD is a line, and I'm going to refer it as YBD equals to MX plus C. Okay, so now we need to find the equation of the line right here, BD. We need to find the gradient M, and we need to also find the y-intersect C. How do you do that? Well, the gradient is kind of given to us already. We know that this line BD here is parallel to this other line given to us, which is y plus 5x equals to 2. Well, if you rearrange that, you get 5 equals to, y equals to -5x plus 2. What's the gradient of this line? -5. So therefore, that -5 is the gradient of our line BD because they are parallel to each other, meaning same gradient, right? So you can immediately rewrite the equation YBD equals to -5x plus C. Now all we need to do is find plus C. What exactly, or how exactly do we find plus C? Well, do we know a point that is on the line BD? So that's a good question. So on our graph over here, we have the point AC. I might just jump a little bit back up. And then BD is somewhere, But the thing is, or the geometry behind your parallelograms, if I describe it quickly, if you have A, B, C, D as an example, and then A to C, and then you get the diagonals from B to D as well, these two lines actually intersect at their midpoints. So AC, BD, for parallelograms, their diagonals actually intersect at a midpoint. And because we're trying to find the equation of BD, we actually do know one point right here, which is x, right? The midpoint of AC. So what you can do is you sub in x, and we know what x is. That is 2, 3, and you can just proceed along. So this is the pre-VCE knowledge that you should probably take in from your year 10, just some geometry. So I sub in y equals to 3, I sub in x equals to 2, and then I am just trying to solve for plus c. So 3 equals to negative 10 plus c, shift 10 to the other side, I get c equals to 13, and therefore y BD, so basically the equation of BD, the line BD, is negative x, or negative 5x plus 13, and there we go. Okay, so guys, that is how you find these that equation to answer part B, and then we move on to part C. This one is a slightly much harder version. We're going to use a bit more space here on the side. So let's read the question first. Given that BC is perpendicular to AC, interesting. So this is our line AC, right, over here. I'm just going to look at the diagram. That's AC. And BC is actually perpendicular to AC. So the graph could go two ways. You can go B comes up over here, 90 degree, or you can go B comes down over here, 90 degree as well. And then we can, try and make a parallelogram A, B, C, D later on. But let's have a think. Where would B be? Would it be up here, or would it be down here? So the question says that the parallelogram has vertices labeled anti-clockwise. So it's a bit weird in a sense, you're like, well, what exactly does anti-clockwise mean? So if B was up here, then your parallelogram would look, like you connect A to B, B to C, and then C to D, maybe somewhere here, right? But then, is that clockwise or anti-clockwise? Well, clockwise goes that way, and immediately, if your parallelogram looks like that, then A to B is a clockwise direction. So you can't take this upper point over here as B, because then that's going clockwise. We want to go anti-clockwise, so the other direction, right? So that direction. So in this case, B is the one down here, in fact. So that's where B is. Yeah, and this one's a bit confusing, but it's why this video exists. So B is down here. We will erase the part about that up there, and you can now start connecting the dots together, right? So A to B would be something like this, and then B to C would be something, B to C would be something like that, and then C to D would probably and that's perpendicular, C to D would probably look something, I don't know, just putting things off the top of my head. Does not look like a good parallelogram, but now we have an idea of what the parallelogram kind of look like. So that's perpendicular. Okay, so A to C is perpendicular to B to C because that's given to us in the question right here. Okay, right. Part I, CI, the equation of BC. We need to find that, right? So essentially, we need to find the equation of this line. Well, we know it's perpendicular to AC. What is the equation or the gradient of AC? We can find that. So MAC, right? How do you find the gradient of a line or the gradient between 2 points? Well, you take y2 minus y1. So up to you. Take whichever y values you want first. So in this case, we're going to take C as y2. So 1 minus 5 over here, y1. And then we'll take the corresponding x values. Okay, so if you took 1 as your y2, then you have to take 5 as your x2. So that's 5 minus negative 1. Minus negative 1, and you get negative 4 divided by 5 minus 1, which is 6, and you get negative 2 over 3 as the gradient for AC. So if you want to find the gradient for BC, right, we know if the two lines are perpendicular to each other, using a bit of our knowledge of linear equations, MAC multiplied by MBC, they should equals to negative 1. And we know MAC is negative 2 over 3. We are trying to find MBC because the gradient is one of the components to find an equation of a line. then you can solve for that. MBC, bring the 3 over, divided by -2, and you get -3 on -2, which is essentially the same as 3 over 2. There we go. So the equation YBC now has this format: 3 over 2x plus c. Okay, so we now need to find y-intercept plus c. How do we find that? Well, again, similar to part B, we need to sub in a point. So what point do we sub in? Well, we know BC over here on our graph has a point that we do know of, and that is point C, which is 5, 1. So you can sub that in. So you sub in the point C. So y is 1, x is 5, and then now we just need to solve for it. 1 equals 15 on 2 plus c, and therefore c is 1 minus 15 on 2, and a bit of fractional subtraction, you get -13 on 2. So therefore YBC should equals to 3 on 2x minus 13 on 2. Okay, so the gradient is 3 on 2, we found that, and then now we found the value of c. Just plug it in and you get the gradient and the y-intercept, and then therefore you get the equation of the line BC. Okay, so that is part I, and I'm just gonna magically make the question pop up so we can continue it down here again. So give me a second and we'll get back into the video. Alright, and we're back. Power of editing. Now we've got these questions next to us again. So let's summarize firstly. So we know YBC has the equation 3 over 2x minus 13 over 2. We know the equation YBD, as we found earlier over here in part B, is -5x plus 13. Okay, so those are the two equations we know for sure. So let's go on to part I. Okay, so what does I say? It's asking us to find the coordinates of point B. So, what's the coordinates of this point? Well, we know the line BC over here, and we also know the line BD, as we found earlier. They have a common intersection, and that is point B. So can we solve for B? Yes, we can. Just do your linear equation, or your simultaneous linear equations. So YBC is 3 on 2x minus 13 on 2. And then you make that equals to YBD. So because we want to find the x value and the y value, right? So I'm going to do some algebra and solve for this. You shift over the x to this side and shift -13 over 2 to the other side. And then what you end up with over here is, well, let's have a think. That's 3 over 2 plus 5, that is 13 on 2, because this becomes 10 on 2. 10 on 2 plus 3 on 2 is 13 on 2x. And then this over here, 13 plus 13 on 2, this becomes 26 over 2, and you get 39 over 2, because 26 plus 13 is then 39. The 2 cancels out. The 13 comes down over here, so x equals to 39 divided by 13, which is a good old number 3. And now you just need to find your y value, which is very simple. You can sub that x into any of these two equations that we had previously. So let's sub it. Sub x equals 3 into y, into the easier one, the one without the fraction, right? YBD equals -x plus 13. And the y value should therefore be -5 times by 3 plus 13, and we get -15 plus 13, and we get -2. So therefore the point B has the coordinates 3, -2. And if we look at our diagram over here, it looks pretty neat, pretty close to it, right? 3, -2, yep, sounds about right. There we go. We got a pretty good like, even if we don't check our answer again, with, it's fairly comfortable because it matches our graph, it matches our algebra as well. Okay, so that's part I, guys. Point B is 3, -2. Right, and then jumping on to the last part of this question is I, find the coordinates of D. Well, we don't know much about D. The only thing we know in connection to point D is this equation right here. YBD equals to -5x plus 13. So If you want to find the point D, similar to how we found the point B, we need to find another line that intersects at this point. So we know BD is one of them, right here, we know that. And we just need to find another line. Well, that line can be AD or it can be CD, up to you, right? And I'm going to pick the easiest route that you can do here is the line AD. So we're going to find, okay, what is YAD? Again, equation is the linear format, general one, mx plus c. What do we know about m? So how can we find the gradient of AD? Well, this one's pretty simple if you think about it. ABCD is a parallelogram, so a lot of geometry involved here. So therefore, AD is parallel to BC. What do we know about the gradient of BC? Well, gradient of BC is 3 on 2, so therefore, you can say MAD is equals to MBC. And that means YAD, just the line, the equation, the gradient of AD is 3 on 2. It should match the gradient of BC, right? So you get 3 over 2x plus c, and all you need to do is find that plus c. Again, just sub in a point, and this time we're going to sub in the point A, because we do know A lies on the line AD. So negative 1, 5, and guys, just need to solve for it. AD, y is 5, and then x is negative 1 plus c. 5 equals to negative 3 on 2 plus c, and c is equals to, well, 5 plus 3 on 2, which is 10 over 2 plus 3 on 2, which is 13 on 2, and therefore YAD is 3 on 2x plus 13 on 2. So now that you have the equation AD, can we find the point D? Well, you can just find the intersection between the line AD right here and the intersection between the line BD, and we do have the equations for both of them. So BD is negative 5x plus 13. I'm gonna write it down here. Negative 5x plus 13. And now we can just solve using simultaneous linear equation. Again, similar to what we did earlier for point B, just make them the same as each other. 3 over 2x plus 13 on 2 equals to negative 5x plus 13. Bit of algebra, you can speed forward the video. So if you want to find the y value, sub it back into one of the equations over here. And the y value, I'm going to sub it back into this equation. So we get negative 5 times by 1 plus 13, negative 5 plus 13, that is positive 8. And therefore, the intersection is 1, 8. And that is it, guys. That is how you solve for this. You need to find the intersection between the two lines, both for point D and for point B as well. And a lot of geometry in between. So guys, I hope you found this video useful. It's a bit of a long one, but it's a big equation or a big question. And if you did find it useful, please leave a like and subscribe to hok'stutoring YouTube channel. I would really appreciate it. Otherwise, if you have any questions, please leave a comment down below and I'll try my best to get into it. And I'll see you next time. Ciao!